So for area moment method, dito sa area moment method, pati sa conjugate beam, mahalaga yung moment diagram. Okay, so ito yung mga basic natin na kailangang malaman. The theta or the deflection or the slope at a point or change in theta yan actually. Change in theta, change in angle. Tapos, the deviations at the tawag. Those deviations are not automatically equal to deflection. Iba yung deflections at deviations sa area moment method. Okay, paliwanag natin yung mga bagay na yan dito sa ating workspace bago tayo gumawa. Wait lang. Wait. Okay, so dyan tayo sa ating workspace. Okay, ang sabi, EI theta AB equals area AB, yun lang. Okay? Anong ibig sabihin yan? Okay, let's say meron tayo beam. Oops. Okay, that's your beam. Tapos, let's say ganito na lang, hindi ko na, let's say merong loading, that's load, kung ano man yan. Okay? Tapos, gagawa natin ng moment diagram. Hindi ko na ituturo maggawa ng moment diagram by parts, ha? Kasi, I believe na nakuha nyo na yung skill na yun sa college. Okay? So, hindi natin ituturo yun dito. So, let's say moment diagram neto is ganito. Let's say ganyan. O kung ano man load yan, that cost yan. That's your moment diagram. Okay? Ngayon, let's say, teka, ibaba natin ng konti ito. Okay? Tapos, let's say this is because of this loading, ito yung elastic curve ngayon ng iyong beam. Okay? Mag-assign na lang tayo ng dalawang points A and B. Let's say this is point A and this is point B. Okay? Kailangan, atong EI, that's flexural rigidity. Okay, that's flexural rigidity, EI. And itong theta. Okay? Theta is change in slope. Not the slope themselves. Change in slope between A to B. Okay? Ano ibig sabihin nun? Let's say na ito yung slope mo for point A. Yeah, let's say that's your slope for point A. Assume nila na tumama. Okay? Tapos, this is point B. Okay? Oops, teka. So, that's point B. Tapos, ang slope mo sa point B ay ito. Yan, tumama na lang din. Teka, zoom natin ng konti. Yan. Okay? So, yung sinasabi natin dito na theta, ito yun. This is your change. Oops, teka. Do that. This is your change in theta between A to B. Nagbago siya, diba? Yung slope natin sa A is going downward, pabulusok. While your slope dun sa B is paangat. Ibig sabihin, bumangon yung slope mo. Okay? Yan ang ibig sabihin ng positive na theta. Ibig sabihin, your slope is, from your first point, your slope is downward, tapos your slope became upward. That is positive theta. Okay? Or siguro, if your slope is already rising from the first point, pero umangat pa siya, o bali, ganyan yung ibig sabihin ng positive theta. Ibig sabihin, basta yung positive theta na AB, ang ibig sabihin yan is nag-rotate pa counterclockwise yung iyong slope. Okay? Ibig sabihin, umangat, bumangon, lalong tumaas. Okay? So, pero kapag ka naman negative theta ang pinag-uusapan natin, ibig sabihin, from one point, rising yung slope mo, and from the other, ipababa yung slope mo. Ibig sabihin, probably ang shape ng beam mo dyan is pa ganito. Okay? Malungkot ang beam mo. Okay? Kasi rising na siya, tapos bigla siyang bumulusok ulit. So, this is a negative theta. Okay? So, dapat ay alam nyo na kung ano yung sign convention natin sa theta at saka sa deviation. Okay? So, paano kinukuha daw itong theta na to? Ang sabi, kumpitin mo lang yung area dun sa AB. Ibig sabihin, kumpitin mo lang yung area dun sa moment diagram. Okay? So, yan. Teka, parang maganda i-highlighter na lang yun. Okay? That is your area AB. Divide mo na sa EI. Okay, no? This is your area AB. Divide mo lang sa EI. From A to B is equal to the area between A to B times the moment arm relative to point A. Anong ibig sabihin na naman nun? Okay? So, dyan ulit tayo sa workspace natin. Paliwanag natin ulit. Tapos, siguro mag-next page na lang tayo. Pero kunin natin yung figure. Ito, kunin natin. Teka. Dapat na bang kunin to? So, anyway. Oops. Iyan. Teka, focus naman tayo sa deviation. Napapansin nyo na sa area moment diagram, syempre, hindi ka makakapag-proceed sa solution kung hindi maayos ang moment diagram mo. Okay? So, mahalaga na marunong ka mag-drawing ng moment diagram ng tama. Okay? So, yan. Dito sa example natin, we have that beam. Tapos, ayun ulit. Let's say this is its elastic curve because of the load na naka-apply dun sa beam. Okay? Sorry. So, ibig sabihin ng deviation, ang sabi rin sa formula ay ganito. EI times the deviation from point A with respect to point B is equal to area AB times X with respect to A. Okay? Let's assume points A and points B na lang ulit doon sa ating beam. Okay? This is point A and this is point B. Of course, may kinalaman ulit ang magiging area natin sa moment diagram sa mga points na yun. Okay? So, this is point A. Tapos, si point B, ito. Ito, tandaan mo, yung unang letter dito, ito yung point. Okay? Si point B naman, siya nang gagaling yung slope o yung tangent line. Okay? So, ito yung tangent line. Let's say yung tangent line. Okay? Tangent line to point B. Ito yung deviation na tinatawag natin. Kung gaano kalayo, let's undo that. Kung gaano kalayo si actual point A doon sa tangent line drawn from B. Pagka binasa mo kasi yan ng buo, deviation of point A with respect to tangent line drawn from B. Okay? Yan yun. Ito yung deviation natin. Diba ito yung slope galing sa may point B. Ito yung actual na point A nung na-deflect na yung beam. Kung ano man yung deflection na yan, PA/B, mako-compute mo yan using this formula. Sabi, area AB, i-multiply mo yan sa moment arm from A. Kaya ang tawag dito is area moment. Kasi nagmo-moment ka ng area. Parang gano'n lang ang idea dyan. Excuse me ulit. Okay. So, ang gagawin mo lang is kunin yung area AB. Okay? Kunin yung area AB to. And dapat alam mo yung centroid niyan. Let's say ito yung centroid niya. Okay? Tapos, imo-moment mo siya doon sa point, hindi doon sa pinanggalingan ng slope. Okay? So, ito yung XA. Okay? Yan, moment mo lang siya. Moment mo siya about this point. So, area na AB, Area na AB, multiply mo sa moment arm niya with respect to point A. Ganun lang kadali ang area moment. Okay? So, given that, sign convention tayo. This is a positive deviation. Okay? When you say positive deviation, the point is above the tangent line. Okay? When you say negative deviation, edi otherwise, the point is below the tangent line. Anong example nun? Halimbawa, meron tayong ganito. Sorry. Ito yung beam. Let's have a cantilever beam. Okay? Tapos, teka, nipisan natin yan. Kulay mo natin ito. Okay. When you say deviation of point B, sabi natin, deviation of point B with respect to A is equal to area ng moment diagram between those points. Tapos, kung ano yung point, okay, diba this time the point is B, doon ka magmo-moment arm. Okay. And the slope is perfectly horizontal. So, when you are saying deviation of point B with respect to point A, so kunin mo lang yung level ng tangent line, nakatapat ng point na hinahanap mo. Tapos, ito yung deviation ng point B from point A. Okay? And this one is negative dahil, sorry. This one is negative. Bakit negative yan? Kasi the point is below the tangent line. Okay? Ulit natin. Negative yung deviation if the, negative yung deviation if the strained beams, sa prop beams, sa cantilever beams is because the deviation in this case is equal agad sa deflection. Di ba? Tignan mo to. Dito sa may simply supported beam, ito yung deflection. Tama ba? Pero, in area moment method, the formulas do not specifically calculate the deformation. Sabi ko nga, deviations are not deformations. Or the deviations are not deflections. Okay? Instead, we calculate deviations and slopes. Then we use these values with geometry to calculate the deformation. So, similar triangles, trigo, sukatowa, ayan. Instead of drawing the moment diagram in a conventional way, we draw the moment diagram by parts. Sabi ko hindi ko na yan i-explain because you already know that. Okay, so we base our calculations on a moment diagram. So we want it to be as simple as it can be. Ayaw natin ng mga magkaroon ng nag-criss-cross na parabolic segments. Okay, parabolic spandrels. Ayaw natin ng parabolic lines. So next, so where do we assume fixity? When you say fixity, kung saan mo ina-assume yung fixed point ng isang beam. Okay. Wala na. Anyway, ipapakita natin yan sa mga examples. Okay, so dyan tayo sa workspace natin. Ito yung una natin situational problem. So, for the beam supporting the loads shown, binigay yung E at saka yung I. So, okay. And yung load, yung UDL pero hindi continuous. So, that's okay. Sabi, what's the value of the deviation of point A relative to tangent line at C in millimeters? Ano yung slope sa C? At ano yung value ng deflection sa point B? Okay, so let's do that sa workspace natin ulit. Sa ating, yan. Okay, and yung figure, and yan na rin yung mga tanong. Wait lang ha. Okay, we're back. The very first thing you need to do kapag ka nag-moment diagram o mag-moment ka or conjugate beam is, syempre, yung moment diagram. Okay? So, syempre, bago yon we have to, ah, wait lang, lipat muna natin to ha. Yan. Okay. Bago yun, syempre, ano muna? Reactions. Okay, so, reaction dito, at saka reaction dito. Kalkyuhin. So, 10 times 3 times 3.5 divided by 5. 16.2. Okay, so that's enough. Okay, then, kasunod, moment diagram. Pag sinabi natin fixity, yung, sabi ko nga, yung fixed point. Okay? Kasi pwede kang mag-assume ng fixity dito. Pero medyo mahirap yan. Kasi, paano mo i-drawing yung moment diagram if the fixed point is this? That's a bit hard. Okay? So, pwede ka na yung mag-fixity naman dito. Wala namang problema yan. Diyan sa may point C. Diyan na lang ako mag-fixity. Okay? Ulit, pag sinabi kong fixity, we are assuming na that support is fixed. Okay? Para madrawing natin yung diagram, moment diagram by parts. Di ba? Kasi kung fixed tong point na to, let's redraw that beam. See, that's fixed. Okay? Binago ko lang same beam, same loadings, pero all supports are not existing. Okay? Tapos may reaction dito. This is 18 kilonewtons per meter. This is 16.2 kilonewtons. Okay? If this is the loading, the type of loading na meron tayo sa beam, ang magiging moment diagram natin ay ganito. Because of this 16.2 kilonewton load, 16.2 times 5, ang moment niya is positive yun, syempre, di ba? So that's first degree. Kaya hindi ko na ipapaliwanag yung paggawa ng moment diagram by parts, ha? Since this is a point load, ang itsura niyan sa shear diagram ay magiging horizontal line. So pagdating sa moment diagram, so first degree line na siya. Okay? So, yan. This is 16.2 times 5. Ilan yan? Times 5. 162, 81. Okay. 81. Okay, tapos, dito naman sa dyan. So, sorry. Ganito naman. Second degree naman. Di ba? Kapag ka UDL, ang itsura niyan sa ang itsura niyan sa moment diagram is tawag dyan, second degree line. Okay. Okay. Pero alam nyo, may feeling ako na mukhang maganda mag-fix. Ang sabi, tangent line at C yung ating reference. So, ito yun. So, malamang ang tangent line dyan ay pag ganito. Tama? Yan, that's your tangent line. Ang hinahanap is deviation of point A relative to tangent line at C. This is the point A. Ito yung slope sa C. Ito yung hinahanap natin sa unang tanong. Kung gaano kalayo vertically point A is from point C o from tangent line drawn from C. Yan yung una natin hinahanap. Okay, so ayun. At ang sabi, mako-compute natin yan. Paano natin mako-compute yan? Di ba sabi, ito yung equation natin. EI, deviation of point A from point C equals, syempre it involves the area of the moment diagram between A to C. Okay, so ibig sabihin, it involves them all. Lahat na nasa pagitan ng A to C kasi this is A and this is C. Okay? Tapos, i-multiply mo yan o i-moment arm mo yan, multiply mo yan sa moment arm from, saan mo ilalagay? Saan mo i-moment? Sa A o sa C? Sa A. Okay, i-moment mo siya doon sa point, hindi doon sa pinanggalingan ng slope. Okay? So, ayun. So, ayun na. Let's calculate. Ito ang moment arm nito from point A. Kasi triangle to eh. Yes, ayan. Ito, kaya rin computein ang moment arm. Okay? Ano i-compute natin? 2/3 ng 5. Oh, let's just say that this is 10/3. This is 10/3. Okay? Tapos, yung sa ilalim, ito, since ito yung base ng parabolic spandrel, remember that this is second degree. So, B over 4 ang sentro niyan, di ba? So, 3 meters over 4. Oh, kinalcue pa talaga. Oops, hindi ko mapakita. 3 meters over 4, that is 0.75, tama ba? So, 0.75 to, 0.75 yan. So, 5 minus 0.75, that's 4.25. Okay? Okay. So, yeah. Compute na tayo. Siguro, sulat ng konti ito. Baguhin ko nga ulit itong setup susunod para hindi ko na nalilimutan yung calculator. Paano yung katulad nakaraan? So, yan na. Area AC. So, yung triangle muna unahin natin. Ito muna unahin natin. So, that's 1/2. Ang base ay 5 meters. Ang height ay 81. Okay, ang moment arm niya mula doon sa point A is 10/3 as shown o as discussed kanina. Okay, tapos plus or minus kasi yung area ay nasa ilalim, that's negative area. So, 1/3 BH, that's parabolic spandrel. Ang base ay 3 meters. Ang height ay, teka, anong height nun? Wala tayong height nun Ito. Ano yung moment na ibibigay ng UDL na to dito sa may fixed point? That's 18 times 3 times 1.5. Sorry, hindi ko pala nalagay pa. 18 times 3 times 1.5. That's 81. Bakit? 81 din. Nag-isip pa. Okay, that's negative 81. Okay, so ulit natin. So, 1/2 BH. Moment arm is 10/3. Tapos negative area. Tapos base height is 81. The moment arm from A is 4.25. Okay, so that's 330.75. Pero ito pa lang yon. Okay? Ito pa lang yun, yung 330.75. You still have to divide it by EI para makuha mo yung deviation mismo. Okay? So, let's divide that. Pero sandali lang, anong unit nun? Anong unit nung itong area times x sub a? So, kung i-analyze mo, yung area ng moment diagram, di ba, naka-meters, sorry. Di ba, naka-meters ka dito? Okay? Meter. Tapos, eto, ano unit nitong moment na to? Kilonewton meter. So, area already, the unit of area is already kilonewton meter times another meter. Tama ba? Okay, kilonewton meter yung moment, kasi that's moment diagram. Tapos, yung dimension na length is naka-meters. Tapos, ito ay naka-meters din. Tama ba? So, ibig sabihin, yung 330.75 na na-compute natin kanina, that's kilonewton meter square. Right? Okay. So, yung nasa ilalim natin, ang binigay sa atin is 200 GPA. Ito. And naka-mm squared. Naku, sa parang hindi consistent ang unit. Pero anyway, syempre, ang gusto natin gawin is gawing kilonewton o gawing newton lahat ng unit at gawing megapascal at mm squared o mm para lahat ay consistent. Okay? Para kapag nagsagot tayo, yung sagot matik naka-mm, naka-newton, or naka-megapascal. Okay? Okay. So, lagyan natin sa baba, that's 200,000 megapascal for 200 GPA. Tapos, yung ating moment of inertia is ano naman, 16 times 10 raised to 7. Hindi ko nalalagay unit. So, para maging Newton at mm din ito, saan ko siya i-multiply? Times 1,000 para maging newtons yung kilonewtons, and times dalawang 1,000 para maging millimeter to parehas, para maging mm squared. So, kapag ganyan, i-multiply natin ito sa 10 raised to 9. Okay? This is 10 raised to 9. Okay? Kasi yung 10 raised to 3, para mo-convert yung kilonewtons. Eh, di ba kilonewton mm squared yun? Kilonewton meter squared. Tapos 10 raised to 3, para i-convert yung isang meter. Tapos, dalawa yun. So, 10 raised to 6. Okay? Pagka pinagsama, 10 raised to 9. Okay? So, just remember that para hindi ka malilito sa mga units. Kung times 10 raised to 9 ba o times 10 raised to ganito. Anyway, let's try solving. Ano ang kalalabasan niya? Oh, teka. Saan ko ba pwesto? Hindi na lang. $30.75 times, ay parang kulang yung 10 raised to 9. Alam ko 10 raised to 12 yun eh. Yan, 0.0103. Pero let's try. Ano ba sagot yan? Oo nga. Teka, sandali. I-analyze pa natin sandali yung unit. Alam ko kasi 10 raised to 12 yun. Yung area, wait, kilonewton meter to kasi naka-moment. Tapos times meters. That's kilonewton meter squared. Kilonewton meter cube pala. Sorry. Kulang. Ulit natin yung discussion ha. Ang unit nito is kilonewton meter. Okay, so ito yung sagot natin. Oh, teka. Yan. The deviation of point A to point C as shown in this calculator is 10.34. Okay, so sulat natin. It's 10.34 mm. Okay, so ito yun. Exaggerated lang yun. That's 10.34 millimeters. Okay, so yun ang sagot natin. Okay. Tapos, slope at C in degrees. Pag sinabi mong slope at C, edi ito. Ayun o. It's angle from the horizontal. That's very simple kasi meron ka ng triangle. Ayun o. 0.118 degrees. Okay? So, ito yung sagot natin. I hope na nakasunod kayo sa discussion. And next is, what is the deflection value at point B? Ito na yung hinahanap. Deflection at point B. Okay? So, sunod na sheet natin yung sagutan. Wait. Okay, so kopyahin natin muna to. Kopyahin. Okay. Pag-isipan mo ngayon, paano mo yan gagawin? Paano mo kukumpitin yung deflection dito? Oops. Ito. Okay, so, actually, kung makita mo to, pwede mong kunin to. The deviation from point B relative to point C. Tama ba? Pwede ba kunin yan? Oo, pwede yan. Okay? Kailangan mo lang kunin yung area nito. Yan o. Area involved between point B to point C. Tapos, i-moment mo sila doon sa point B. Okay? And there you have it. The deviation of point B with respect tangent line at drawn C. Okay? Drawn at C. Pero ayoko gawin yun. Okay? Pakita natin na for this particular question and in deflection sa B, mas magandang drawing ng moment diagram by parts na ang fixity ay nandun sa B. Okay? Tingnan natin. Mas madali kasi yun eh. Wait. Brain natin to. Okay. Ang sabi natin, mag-a-assume tayo ng fixity at point B. Ibig sabihin, we will assume that this point B is fixed. Okay? Then, with that fix, you have the reaction dito na 16.2. You also have this 37.8 sa kanan. P2.4. Okay, tapos para naman dun sa kabila, 37.8 times 3. Dati yung calcu. 37.8 times 3. That's 113.4. Okay, tapos for this UDL, that will cause a negative moment para dito sa beam. So, ganito magiging itsura niya sa moment diagram by parts. Ganito. Again, nasa second degree line. Okay, tapos anong ano yung kanyang value? Ano yung magiging moment niya dito sa pader? That's 18 times 3 times 1.5. So, that's 81. Negative 81. Okay? So, if you are looking for the deviation of point B, if you're looking for the deflection at point B, deflection at point B mismo, So, ganito gawin natin. Diba, ito yung original position ni beam ABC. Ito yung mga supports niya. Tapos, ito yung deflected na shape niya. Yan. We want the deflection here at this point. Ito yung gusto natin. Yan. Tago muna natin yung kanina. Sensya na, medyo runny nose talaga. Kaya, pinapost ko yung audio. Okay. So, hindi po natin yan alam. So, pero ang alam natin, kaya natin kunin yung deviation ng point B with respect to tangent line drawn at C. Okay, para saan naman yun? Drawing ulit natin yung tangent line, ha? Oops. Ito po yan. Yung nating blue, yung tangent line. Okay. Paano konti? Yeah. Okay. So, eto, this is deviation of point B relative to tangent line drawn at C. Para saan yan? Okay? Kasi ang gagawin natin, kukunin natin yung height ng triangle na to. Okay? Diba ito triangle yan? We already know the slope here. Okay? Alam natin yung angle dyan. So, kaya ko makuha tong side na to. Okay? So, kapag kinuha ko tong side na to, tapos minus ko yung deviation, hindi ang makukuha ko yung ano na mismo. Yung, itong deflection na tinatanong dun sa problem. So, let's say ito, yung total na height ng triangle. Let's say that's y. So, pwede natin sabihin na deflection at point B is equal to y, the height of that triangle, minus the deviation of point B relative to point C. So, yung deviation muna ang unahin natin. Okay, so deviation of point B relative to point C equals yung area from B to C. Okay? Tapos, yung moment natin sa point B, kasi yung point ang pinag-usapan natin, not the origin of the tangent line, divided by EI na lang. Okay? So, let's try to compute for that. Okay? So, sunod na lang sa calculator. Area, BC, dalawa yung area sa BC. You have this triangle and you have this parabolic spandrel. So, for the triangle, let's say 1/2, base natin is 3, ang height natin is 113.4. The moment arm niya from point B, ito, okay, is 1 meter. Kasi 3 meters to eh. Yan, centroid niya nandyan sa 1 meter. Okay, times 1 minus 1/3. Ang base natin ay 3 meters ulit. At ang height natin is 81. At ang kanyang centroid is 1/4 ng 3. O 3/4. That is 0.75. Okay? So, ang sagot sa taas ay 164 ops. Yan, totoo. 164.10. Okay, times 10 raised to 12 na natin. Tapos, sa ilalim, edi yung 200,000 minus. Oops, wait. But minus 200,000 times yung I na 16 times 10 raised to 7. Okay, so ang deviation ay, deviation natin is 164.1, 200,000, 16 times 10 raised to 7. Okay, so the answer is 5.13 millimeters. Pero hindi pa yung deflection na baka ma-excite ka. Ito pa lang yan. Mula yan dyan hanggang dito. Okay? E paano yung triangle? Yung Y. Okay? Itong length na to, ito yan, which is 3 meters. Okay, so 3 meters. Ito ay 0.118 degrees katulad ng sagot natin kanina. Let's just round that off. Round off na lang natin. So yung y is equal to 3, tangent 0.118. Okay na yan. So yung y is, 3,000 pala, para naka-millimeters. 6.178. 6.1785 na lang millimeters. Okay? Ba't ganun? Parang hindi ko natandaan itong mga numbers to. If we are correct, then pwede natin kunin yung deflection. Okay? Kaharang pala yung calculus. Mahirap pala yung setup pagka pinapalitan ulit yung calculus. Wait lang. Okay. Ano ba yung sagot? Alam ko 2.78 to eh. Alam ko ito sagot dyan, 2.78. Parang may mali tayo dito. Excuse me. I think meron tayong error dyan. 6.17 minus 5.13. 1.05. Wala namang ganun choices eh. Anyway, i-try natin i-correct. Parang may mga hindi ako naalala ng values dyan. Wait lang ha. Area, 1/2. Base is 3. Height is 113.4. 113.4 ba yung nalagay ko kanina? Parang hindi. Minus yung area sa baba, 1/3. Base is 3. Height is 81. Moment arm is 0.75. Okay, then EI. Tama. Yan nga. 109.35 to. Mali yung computation ng area kanina. Ulit ko to. Tapos, 16 times 10 raised to 7. 200,000. Okay, so that's 3.41 pala to. This is 3.41 millimeters. Okay? So if we try to subtract 3.41 from 6.17, then dapat sa tama makukuha natin yung deflection sa B. Tama ba? So that's 6.1785 minus 3.41. That's 2.77 pag niround off mo. Or that's close enough to the correct answer na 2.78 millimeters. Okay? So, ganun lang. Sabi ko nga, moment diagram, moment mo lang dun sa point. Okay? Kailangan mo lang masanay. Kung yung gusto mong masterin na method, kailangan mo lang masanay sa deviation, sa paggawa ng moment diagram, okay, sa trigonometry, etc. Okay? Dali lang yan. And isa yan sa mga baon ko dati personally ng board exam. The area moment. Pero, if we compare area moment sa conjugate beam method, mas mabilis pa rin, okay, most of the time, ang conjugate beam. So, let's